A technique that's often used for working with DTO model classes is a new project, say movies.shared. That would then contain the DTO classes. Both the client and the API would reference this project. This diminishes code duplication, and it ensures that changes only have to be made in one place. It's also useful when you want to be able to deploy the model classes independently. A shared project results in an assembly, and that is the unit of deployment. This is a good approach when you are in control of both the client and the API, and when both are built in platforms that can target that shared assembly or shared project. Another technique that diminishes code duplication and ensures that changes only have to be coded once is adding the DTO model classes in one project, say the API, and adding them as a linked file in the client project. This ensures that the files only exist in one place, the API project, but are packaged into the API and client assemblies when compiling. So there's no shared assembly in this approach. This again is a good approach when you are in control of both the client and the API, and when the code you are linking can be compiled at client and API level. Both of these techniques only work when you have full control over the client and the API source code. But in a lot of scenarios, the API isn't built with .NET or .NET Core. It might be built with Node.js, for example. In other scenarios, the API is built with a .NET implementing platform, but it is built by another team or another company, and sharing a models assembly is not an option. And in fact, it shouldn't matter with what technology the API is built. I don't know with what technology Google builds their APIs, but I do need to be able to integrate with them, and that's what we're trying to mimic here. This is a course on working with HTTP client, regardless of what technology the API is built with. We looked at the OpenAPI documentation in the demo, and we saw the exposed models. That is all a client needs to know. So we can now do two things. We can simply look at the documentation and create client-side versions of the models, or, and that's probably the better approach, we can use a tool to generate them. Let's have a look at that next. To generate DTO classes, quite a few options exist. Most of the current ones rely on there being some sort of specification available that describes the API. An often used format for that is OpenAPI, which is often referred to as Swagger. In other words, once an API has support for OpenAPI, we can generate client-side DTO classes, or even a full client with calls to all resources available through the API. And there's a few options we have. One is Swagger CodeGen. You can find it at the URL on screen. But as it's Java-based, you do need the Java runtime installed of your machine. But as it's Java-based, you do need the Java runtime installed on your machine. If you don't want to do that, which I totally understand, there's an online version available at the URL you see on screen now. Another option is using NSwag Studio. NSwag is much like Swagger. It's an implementation of OpenAPI you can use in your API projects to generate documentation. NSwag Studio is a Windows application that can generate DTOs and clients from an OpenAPI specification. You can find NSwag and NSwag Studio via the URL on screen. We will look into this one with a demo. Lastly, we can generate DTOs and code inside of Visual Studio via the Add Connected Service option. Behind the scenes, this one actually uses NSwag. It's on par with the current version of OpenAPI, which is version 3 at the moment of recording. We will start with looking into this, And after that, we will tackle NSwag Studio. Our API is up and running. We need the OpenAPI definition to generate our classes from, which you can find at the URL on screen. So let's navigate to it. Let's right click and save it. I've navigated to my Pluralsight demo folder. Let's save it here as movies API swagger.json. Alright, that takes care of that. Let's switch to Visual Studio and let's quit debugging. What we want to do now is right-click the movies.client project and choose to add a new connected service. Via such a connected service, client applications can connect to APIs through code that's generated on each build. It's typically used to avoid having to write much redundant boilerplate code. We see here that we can add a service reference to OpenAPI, gRPC or WCF web service. Swagger is an implementation of OpenAPI, so this is what we need. Let's choose to add one. Let's choose OpenAPI. And let's navigate to the file we just saved. There we go. Then we need to input a namespace for the generated classes. Movies.client.models sounds like a good value for that. It implies we are generating models, DTOs in our case, for use by our Movies client app. We don't need to provide anything for the class name, that will be generated by default. And then we need to choose the code generation language. We want to generate C# classes, but TypeScript is also an option. So yes, you could use this from an Angular client. Let's click Finish. And there we go. We see that a few package references are added. And one of those is very interesting. An NSwag related package. And that is indeed what is driving this functionality underneath the covers. We also see a reference being added to JSON.NET. JSON.NET is a popular JSON framework for .NET. As you may or may not know, .NET includes its own very fast JSON parser, system.text.json. It's good for most scenarios and it keeps getting better. But for some advanced functionality, you'll often still need something like JSON.NET. In fact, we will encounter this again later on in the course. For now, just know that it's a requirement for generating client-side classes when using the connected service approach. Let's continue by clicking Close. In our IDE, we see a new OpenAPI reference with the Movies API swagger.json file, which we saved previously. If we look at the object folder, which contains the files that are generated on build, we find a Movies API Swagger client. Let's have a look at that. Generation of this, by the way, happens on each build. If you happen to run into an error at this moment and you don't see the generated file, chances are likely that you're running the code from a directory with spaces in the directory name. I ran into that previously as well, and apparently this tool doesn't play nice with that. So it's best to switch to a directory without spaces in its name. Anyway, it seems like a lot of stuff was generated. If we scroll all the way down, we see that our DTO classes were generated. There's a poster for creation, there's a trailer class, etc. But a lot more than that has been generated. Over 1,000 lines of code. If we scroll back up again, we see that methods were generated to integrate with the API. For example, the Movies Async method that accepts a movie for creation and a cancellation token can be used to create a new movie. It uses HTTP client to call into our API. To achieve that, it uses HTTP client to call into our API. And if we scroll all the way up, we see that all of these methods are encapsulated in the newly generated Movies API Swagger client class, which we could now go on and use directly in our code. So this is pretty great to get started fast. And even better is the fact that we can simply regenerate by building when the OpenAPI definition changes. Yet, is this really what we want? We quickly scanned the code, which already told us it uses JSON.NET. That's often a requirement for advanced cases, but for simple cases like getting a movie, better options like the built-in serializer exist. There's also no mention of an HTTP client factory, which is an essential component to avoid socket issues, as we will learn later on in this course. And also, we didn't see an easy way to get some flexibility in regards to what is generated how. So, we are a bit stuck here. Something like this is great for throwaway clients. In other words, if you need to get something up and running really fast. But I would not advise using it in production scenarios. So let's get rid of this. And let's have a look at how we can gain some additional flexibility by using NSWAG Studio directly in the next demo.